Okay, so we are going to be talking about the 2009 AP Calculus BC free response question, number 4. So we want to carefully read our question. It says the graph of the polar curve is r equals 1 minus 2 cos theta for all numbers in 0 to pi, and let S be the shaded region in the third quadrant bounded by the curve and the x-axis. So the S is right here. So this is the bounded region. The first one we're going to start with is A, and it says write an integral expression for the area of S. So now we've got to think area, and we've got a polar curve. So we want to think area, and we're going to write down the formula over here. Polar area. And that is 1/2 integral from A to B of r squared d theta. So that's our side note, and this isn't really something that you have to write down, but just think in your head that this is the polar area. So I wrote down the equation of r, and I wrote down from 0 to pi, and I also have this little graph so we can keep looking at it for a visual. So right now we have to find out where our integral is going to go to. So we want to find where this point right here and this point right here. So we want to know where what r of 0 equals, and we also want to know where r of theta equals 0. So just looking at this part right here, we can go to our graph and we see that at -1, r equals 0. So, -1. Also, if we do the math for that, we can just look at r equals 1 minus 2 cos theta, and we can plug in the 0. And cos of 0 equals 1, so it would be 1 minus 2, which equals -1. Now let's think about this section, because this is going to be the most difficult part. So basically to find that, we're just going to set the r function equal to 0. And we're trying to find this point right here. So we're going to set that equal to 0, and we're going to solve for theta. So we're going to subtract 1 on this side. And then we're going to divide by -2. So now we're going to think, where does cos theta equal 1/2? So on the test, you're going to have to do this by yourself, but we're just going to give you a quick visual. If you look at this unit circle, you can tell that the x, the cos value, is 1/2 at pi over 3. And it's also 1/2 at 5 pi over 3. But let's remember, let's go back to this, that we can only have the theta from 0 to pi. So the only correct answer can then be that theta equals pi over 3. So we now know that our graph at 0 starts right at -1. And we also know that at pi over 3, it equals 0. Okay? So this is going to help us set up our integral now. So the area is going to equal 1/2, remember from up here, from 0 to pi over 3. And then our r, which is 1 minus 2 cos theta squared d theta. So basically right here, we were just determining where the graph starts and where it equaled 0 and finding out this point. And then over here, we're finding out where this point is at. So we found it at pi over 3, and that's basically just setting up our integrand and then plugging in everything else into our polar area equation. Okay, so now we're going to be looking at our B question. It says write an expression for d of x over d theta and dy d theta in terms of theta. So we want to find dx d theta and dy d theta. And let's remember that our function is r equals 1 minus 2 cos theta. Okay, so we want to find both of these. So let's just take a step back really quick and remember that x in terms of r equals r cos theta, and y in terms of r and theta equals r sine theta. So basically looking at this, you want to take this function right here and turn it into the derivative for this. So that's really going to look like dx d theta equals, and it's going to be, so if you look at this, we're going to take the derivative of r, which is dr d theta. Okay, and then times just this right here, cos theta. Remember, you're going to take the first derivative times the second plus the second derivative, which would be sine theta. And it's actually going to be a negative, so we're going to put a little negative there. And then just the first one, so r. So that's your first equation. And then you're going to have dy d theta equals, so we're going to take derivative, so dr d theta, times just the second, plus, and we're going to have we're just going to leave that r right there, and it's going to be the derivative of this, which is just cos theta. So those are the expressions, but now we have to plug in everything. Okay, so we need to find what the derivative of r is going to be, plug that in, and then just plug in r, and then we're pretty much done. So I'm going to write down r equals 1 minus 2 cos theta, and we are going to find dr d theta. Okay, so if you just think about it, 1, nothing, and then what's the derivative of cos? It's sine, but it's negative sine, so it's going to be 2 sine theta, because 2 negatives make a positive. Okay, so now we're just going to write all these out. So dx d theta equals 2 sine theta, and you might, after you write all these out, have to simplify, and then our r, 1 minus 2 cos theta, and then negative sine theta. Okay. Okay, so I just kind of distributed this sign and kind of wrote this neater. So if you can see, we have 2 sine cos and 2 sine cos over here, cosine. So we're going to add those together, and we are going to get 4 sine theta cos theta, and then minus the sine theta. So that's the simplest you can get it, and remember, you always want to write these in so we stay in the right form. So that's your answer for dx d theta. Okay, so now that we've done that, we're just going to have to go and find dy d theta, which won't be that difficult. Okay, now we're just going to find dy d theta. So we're going to plug everything in. Let's see, dy dr d theta we already have over here. It's going to be 2 sine theta. Okay, and then we have times the sine theta, and then plus the r, which is 1 minus 2 cos theta, and then times the cos. Okay, so I just did this really quick. You just distribute these, and then you're going to simplify, so putting those together, and you can put these together. Okay, and once you get there, you can't do anything else. You could just leave it as this and then leave these, because in their answer they just left it that way, but either answer is correct. So these are our answers, and don't forget to do that little equals. And these are going to be our answers for letter B. And that's all you guys have to do. So we're doing number 4C, and I always feel like these are the harder ones. It's a little bit harder, but it's actually not too tricky, so we're gonna bear through it. So it says C, write an equation in terms of x and y. That is going to mean linear. So like we said, y equals mx plus b, or rather y minus y1 equals m x minus x1. So this is probably the form that we're going to want it in. This is the linear form, okay? So let's continue to read the problem. So it says, the line tangent, okay, so you're going to find the line tangent to the graph of the polar curve at the point where where theta equals pi over 2, and then show the computations that lead to your answers. That's just showing all your work. All right, so I wrote our little equation up here just for a reminder, and I'm going to write theta equals pi over 2 just so we remember that as well. And I'm just going to write our r equals 1 minus 2 cos theta. And now you don't have to do this, but this is just a reminder. You know, you're going to have that in your question. You don't have to rewrite it. So first things first, we need to realize that we have got to find the slope. Okay, so we need to find the slope. And the only way we are going to find the slope is if we find the derivative, okay, the derivative of this r, okay? So basically we want to find dy dx, which is 1 pi over 2. So this is the same thing as saying dy over d theta over dx d theta, okay, at pi equals, theta equals pi over 2. Okay, we're going to need to find the answer for that. So let's quick look back at our B answers. So we already found dx d theta, and we already found dy d theta, okay? So literally all we have to do is take these, plug them into here, so rewrite that equation, plug in that pi over 2, and you've got your slope. So let's do that really quick. So we are going to say that this equals, and we're okay, so with that previous equation, we're now going to look over here and we're going to say, okay, so we want to know where cos of pi over 2 equals and what sine pi over 2 equals, okay? So if you think about it, it's the one that goes straight up, which is going to be over to the right 0 and up 1, and that's your x and y. And so the cos of pi over 2 is going to be 0, and the sine of pi over 2 is going to be 1. But, so here's the equation, right, that we had from before. And we're just going to look at what we've got over here because this makes it really simple. And then you just look over here and you just fill in everything that you've got. So we're going to take this and see that sine pi over 2 equals 1. So 1 squared is still 1. And 1 times 2 is 2. So we're just going to write that down right here. And that's what this section is. Okay, I'm just going to mark that up. So you know that right here, this 2, is where this is, okay? Okay, and then we're going to add right there, and we're going to look at this part. So we're going to see that cos pi over 2 equals 0. So 1 minus 0 is 0, and then times 0 is still 0. So it's going to be plus 0. So looking back at this 0 is right here, okay? And remember, cos equals 0. And anything times a 0 is going to give you 0, so that's really easy. Okay, and then we're going to divide, and we're going to look at this little section right here. before the subtraction sign, and we're going to say sine pi over 2 equals 1. So 4 times 1 is still 4. Okay, and then cos equals 0. So it's going to be times a little 0, and that's going to give us 0. Okay, then we're going to look at sine over here and make sure you put that subtraction right there. And I'll remind you again that this 0 is from looking at this section. And we're going to put that subtraction, and then we're going to look at sine pi over 2, and that equals 1. So it's just going to be a little 1 right there. So, and make sure all my calculations are up to par. Okay, and so it's going to be 2 over negative 1, which is just negative 2. So this is our slope. This is our m, okay? So m equals negative 2. And just a real quick reminder, you might be thinking, well, why did we find dy dx to find the m? So when you have an equation, no matter what, and you've got it in these terms, you want to, in order to find the slope, you've got to find the derivative. That's how you're going to do it. So looking back from what we learned before, we've got y minus y1 equals, and then we've got our m, which is now we know is negative 2. Okay. So we now know that the slope is negative 2, so we're going to put that in there where our m would be, and then x minus x1. Okay. Now we just got to find, and I'll circle it with my silver marker, we just got to find these, right? Because we still got to find those. So we've got the gist of this problem. So now you might be thinking, how in the world am I going to find these? And it is so simple, okay? So we're going to look at our graph. We're going to look at this graph, and we're going to think, you know, theta equals pi over 2. So if we go to pi over 2, which is right up here, right? It's right there. Got our little pi over 2 line right here. And we already know that this is pi over 3, right? So this point right here is pi over 2, which is 0 and up 1. Okay? So x equals 0 and y equals 1. You're mind blown right now. I know you're mind blown. But you can do that, and you can also plug it into the equation, but I think that this is the easiest way, and all you literally have to do is just know that theta equals pi over 2, x equals 0, and y equals 1. Okay, so now we know our x's and y's, and now all we have to do is plug them in. So y equals 1 equals negative 2, x minus 0, okay? So we're going to rewrite this, and we're going to say y equals 1, because we added this to this side. Okay, and we're just going to distribute this to in here, and technically to here, we know that's going to be 0, and so it's going to be 1, and then minus 2x. Okay, and then our big whopper y equals, and this is just my final answer, I feel like writing it better, looks like that. So that's our answer, y equals 1 minus 2x, and that is your linear function that they want. And we plugged everything in, we found x and y, we found the derivative. It was all pretty easy. All of this stuff really added up to each other. You know, originally we just had to find the area. That was kind of a separate question. Then we just had to find what dy and d theta equaled and what dx d theta equaled. And then we just basically plugged that in and found what our slope would be here and what our tangent line would be. So hopefully that was helpful to you, and I gave you a little way to solve question 4. It wasn't too much of a hard one, so hopefully it was easy to follow along with.